Hello. Uh, I figured in honor of AP exams coming up, I should start doing math review for calculus, and this is one of the things that I noticed I don't think a lot of people are gonna know how to do. It is a very niche topic. Not You don't see it very often in calculus. I think I've seen it once throughout my whole experience of calculus. You really don't see this. So let me make this more clear. These are ones, not i's. Okay, so what exactly is this? This is the limit proof for e. This is equal to e, 1000%. It's not a question mark. We definitely know this is equal to e. But I think the question is why is equal to e, because you can just memorize this, of course. But the problem is this is so specific. It is such a small aspect of limits that it is doubtful you're going to remember this. So I'm going to show you a couple skills that can help you evaluate it to actually get you to this answer. So we definitely know it's equal to e, but for our sake, we're going to say it's equal to another variable, and we'll call that variable, well, we know it's a constant, of course. This is a convergent um, sequence, I guess you could say, or function. So I'm going to look at this thing from a couple different approaches, and I'm going to talk about which one's the right one. So we will say this is equal to, what's a good number? What's a good letter, actually? We'll say it's equal to x, because I'm lazy. I don't want to think of another one. Alright, so let's talk about what you shouldn't do when you see this. Number one, the first thing you don't want to do is you don't want to see, oh, as this goes to infinity, this is going to go to 0. And then you do, oh, blah, 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 1 plus 0 to the n is equal to 1. You don't want to do that. Because that, like, seems right. But the problem is, this is not telling the full story. So, what we need to make this into is we need to make this into a continued statement. Or not continued statement, a continued thingy-mabobber. I don't know what to call it. You doing some simple algebra, you can say that 1 is equal to n over n plus 1 over n. We kind of get how we get here, right? This is not a stretch. So you might say, okay, well the inside function, whoopsies. Well, the inside function, the limit as this approaches infinity will be 1. This is just getting 1 to the n. Yeah, you could probably say that in more confidence than you can say this, but it's still not right. The reason for why it's not right, my guess is this one right here. And also, like, the rate at which this is increasing, this 1 is making an impact. So, at least that's what I think it is. It's not, like, really clear why this doesn't work, aside from just that ex exponentials with limits are just always going to be weird. You can't really do the inside limit if there's an exponential out there. It's like you just got to evaluate this. It's growing at such a fast rate that like you can guess, you can say it's going to be approaching 1, but as we're seeing with this, you're wrong. So that, okay, we've lost all hope. What is there to do? This is where this gets really tricky. So the first thing we need to do is we set this to a certain value for a reason. We say that the limit of, we're going to do that algebra again, 1 over 1 plus, or 1, n over n plus 1 in the n. Well, bam, so we're going to keep that, right? And we're going to do that. We're going to do 1 plus, or n plus 1 over n to the n. We say n approaches infinity is equal to x. Sorry, equal to x. Now, I hate this. That n up there looks terrible. So my guess to what to do next is the ln both sides. It's a little stinky to have the limit of something inside an ln function, but that's exactly what we're going to talk about. So basically, it's going to allow us to pull this down. Whoops, not me to do that. This is going to allow us to pull this down, and this makes it a lot easier. So because this is just a value that n is approaching, by limit rules, you can kind of just plop this in here. I don't think a lot of people know that. It is something you can do because this is just a value n's approaching. It's not like... It's kind of like how if you have like a constant on the outside, you can multiply it to the inside. It's a little silly. Limit rules are weird, but that would work for ln. So you just have ln of n plus 1 there. And everything is, and then whoop bam. That I think is probably the hardest part. The rest of it's pretty easy. If you know like a little bit of calculus, you can figure this out. You have to do the limit n versus infinity and ln of n plus 1 over n equals ln of x. Okay. Now, if you've done L'Hopital's, like a lot of L'Hopital's, enough to be like, you know where this is going, right? Well, then you probably know where this is going. The next thing to do is we're going to move it all over here. We're going to say that through algebra rules, you can say that the ln of n plus, let me just roll over here, n plus 1 over n is all in the log, all over 1 over n equals ln of x. Now we just do L'Hopital's. And I'll be honest, now that I think about it, the way I did it was probably worse. You probably don't want this. It might be actually easier to, let me erase this, to go back and just keep this as a 1. Oh, that's the wrong tool. As a 1 plus 1 over n. That makes this a lot easier because let me see two things. And when you do chain rule, the limit of n approaching infinity. Well, what's the limit? What's the derivative of this, right? So we're going to take the derivative of this and the derivative of this. So what is the derivative of this? Well, it's going to be 1 over 1 plus 1 over n times the inside derivative, which is going to be 1. Because since 1's a constant, it's 0. So then the derivative of this is negative 1 over n squared. And then guess what? Right here is the same thing. So it's going to be negative 1 over n squared too. Now, this seems doable, right? We can cancel these out. And then we just have to find the limit of this. Which, if you don't know, I mean, you can kind of figure this one out. This is a limit you actually can evaluate. What is as n approaches infinity? 1 over n approaches 0. Wah, wah. So now it's just 1 over 1. And then, oh my gosh, this is equal to 1. So this is equal to 1. And then you do e. You have to exponentiate. both sides. So you said it's e, and now you're left with e to the 1 equals x. And that goes all the way back up there. So this is the limit proof of e. I know my handwriting is very sloppy, but that's essentially like all you need to know. This is a very, very hard thing. I spent a good 30 minutes trying to figure it out. It's not easy. There are a lot of traps here. One of them is just trying to evaluate this, and then one of them is this, because I did this and made it a lot harder. So I think a good thing to do would be to know how to evaluate this limit, to learn how to do it, because it helps. It does help to know how to do this. There are a lot of limits that you're gonna get that are really, really stinky, and this is one of them that's like sort of on the more difficult side. But if you know how to do it, then I feel like you can do a lot of limits. This is one of the most, this is by far the most challenging one I've faced. So, yeah, no, I think you can do it. I think the hardest part is probably the ln, understanding that, why that works. I can't really explain why it works. I just tried it, and then I was like, it probably works because this is just a value. It'd be like the same thing you put, like plugged in this as 1, or this is approaching 1. It'd be a little different, or it'd be like the same thing, but it'd just be different because it's approaching 1. Regardless, the limit of that would still be this, right? So even if the ln of this was on the outside, it'd be the same thing as if it was on the inside, right? So the limit doesn't, like, it doesn't really matter where this ln is, but it helps you a lot to put it here, right there. So yeah, that's what my line of reasoning was. I don't have much to say about this. Don't expect it to be on the AP exam, but you should still know how to do it. It's unlikely that it will be. Like I said, this is a very niche topic. There's not a lot of times where they're looking for you to prove E or even know this limit. Most of the time they'll give it to you. Regardless, it's still really helpful to know. You learn how to evaluate limits very well, and that is something that a lot of people like, at least that I've noticed. Now that we're getting, at least my class is getting more into series, this is coming up a lot. So this is one of those things where it's like you gotta know how to do it. At least the basics of it. You don't need to know like ln rules of limits. Like that's something that's so incredibly unimportant. But yeah, that is the limit proof of E.